Well, hello, this is Nitin Dahad with the Times, and I'm here in Cambridge today talking to Haydyn Povey, who's the founder and CEO of SCI. Haydyn, hello.
Hello, Nitin.
How you
Thank you for
doing?
meeting us. Very well, thank you.
So, Haydyn, you've got some news today, and the news is that you've announced a significant seed round, not disclosing the amount, but tell us what that is, and then we go into a little bit about what you're up to.
Yes, so we're very lucky, very privileged to be receiving investment. It's led by Mercia Ventures, which is a UK-centric deep tech fund. So they are leading, and we're bringing in funding from other VCs as well as a number of high net worths, both in the UK and in Silicon Valley.
Now, SCI is started a year or two ago, and you came with this idea to develop secure, memory-safe devices, chips based on CHERI, which is a technology developed through various organisations. We'll talk to Professor Robert Watson later, but just give us a little bit of background.
So cybersecurity, everybody knows, is one of the big global challenges today. McKinsey recently put out a report which estimated the total impact of cyber attacks at $10.5 trillion, which is actually about 9% of global GDP. So $1 in $10 is being lost or being impacted by cyber. This is the big challenge of our days. Now, working with governments, the US, the UK, and through various organisations, including the University of Cambridge, there's been a development in how we start to address these, to address the fundamental issues around memory safety as opposed to trying to...
So memory safety has been around, like the issue has been known for many years, 40 years or probably more.
Yes.
But I think it's never been addressed because nobody had the wherewithal to do it.
It's one of those very challenging issues. Computers were never designed to do what we're asking them to do today.
Yeah.
So the problems were first identified back in the 1970s. There's obviously been other mechanisms to try and address this, things like formal methods and advanced languages like Ada and more modern Rust. And those all help. They're all good things which move it in the right direction, but they're only as good as the people using the tools. And so we've fundamentally had to do a reworking of how computers operate and bring in the CHERI technologies, capability hardware enhanced RISC instructions, which extend RISC-V and other ISAs to bury some of these requirements deep into the DNA of the chip.
Yeah. You started this off with, I think, £1.5 million worth of government grant funding along with low risk to bring, what was the objective?
Absolutely. So fundamentally, we've looked at what is a minimal instantiation for CHERI, and it's a processor core and system called Chariot, which was...
And you've got the programmer's manual
We've got
there.
the new programmer's manual here written by David Chisnell. The nature of Chariot, it was created out of Microsoft. It's been donated to the open source, and both ourselves and Google and Microsoft are managing it in the open source. But of course, you actually have to move that into a real world product. The biggest challenge for CHERI and Chariot right now is that you just can't commercially buy it. And so we've been tasked by the government as part of the DSBD, Digital Security by Design program, to look at how we create a commercially viable device, how we take that to market through distribution partners like EPS. So we've been working very hard on the core, on the system, on the packaging into a chip, and also on the software side of things, from the tools, the compilers, through to fully compartmentalized real-time operating systems.
And I think I'll talk to David later, but the key to CHERI is that compartmentalization, so that you'd minimise that attack vector surface, attack surface.
That's correct. I mean, the compartmentalization is very focused on, in effect, minimizing the blast radius, of an attack, meaning that it acts like a run-flat tire. You may know that you've got an issue in a compartment or in part of the system, but you also know that the attacker can't easily link these attacks together to create a viable exploit. So it really does aim to secure in all of the forms, you know, confidentiality, integrity, and availability of the systems. We really can, through CHERI and through Chariot, provide a much better solution. Now, it fundamentally solves the memory safety issue around, you know, pointer mismanipulation, around free after use, use after free, and around heap and stack and other issues, and creates a much more resilient framework. And so this is really targeted at a lot of critical infrastructure applications or regulated industries.
And that is part of a movement, I think, from governments and I think you talked about pathway to standardizing memory safety over the long term. Is that right?
That's right. So we see it both from government agencies here in the UK, NCSC, Ollie Whitehouse, who's the CTO of NCSC, has publicly...
That's the National Cybersecurity Centre.
That's right.
Yeah.
So he's publicly spoken about this, and similarly in the US, the White House, the Office for National Cyber Defense have explicitly requested companies in the US to have a roadmap for memory safety by the end of 2025, which really is no time at all in the development systems.
Yeah, yeah.
Yes.
So okay, you've got this funding. You're 25 people already. You founded this with a purpose to get memory safety to market in some form. What are you doing with the funding, and what can we expect from SCI?
So as always, it's execution orientated at this point. The technology is very well proven at this point through universities such as Cambridge, Oxford, Manchester, and around the world. So we all now have formal proofs that the technology is in a strong state. It really is about execution. So from our perspective, it's the deployment of a multi-project wafer and into chips, getting those into the hands of our customers and looking at how we exploit that. Of course, we also have a roadmap of products, higher performance as we evolve, and the need to work with our customers to engage with them, to ensure that they're successful with their new products into quite a wide range of industry segments.
We'll go to industry segments in a minute, but then, so your roadmap will include delivering devices, but also delivering IP, is that right?
Correct.
Microcontrollers specifically.
Yes, our business model right now is twofold. So while the Chariot core is open source, there's a lot of work to support that and to build out the ecosystem to create viable devices. And we're working with partners around that and customers. And then secondly, as you say, the number one challenge for Chariot right now, and for CHERI right now, is availability of physical commercial devices. And we are looking to fix that with the launch of our Iceni devices. We'll be talking more about these at Embedded World and the evaluation platforms we have for them, and then the availability of the chips into the second half of the year.
Okay, and in terms of applications, I think what you were explaining is because of how you started, a lot of this is going to go into sort of government-driven requirements and regulatory requirements. So, for example, you talked about smart energy and medical, but just elaborate on some of the application areas.
Yeah, absolutely. If we look at smart energy as part of critical infrastructure, there is a requirement to better use energy, to embrace net zero, so wind and solar and all of these sort of things. But it means that we have to digitize the grid and we have to digitize into people's homes through the smart meters. To rebuild national grids globally is hundreds of billions of dollars, and we want to do it once, and we want to make sure that it lasts for 50 years or longer. And that's just the distribution part. And then obviously when we look in people's homes, the way in which white goods, electric vehicle charging, battery wall charging, inflows and outflows of energy needs to radically change, and governments are trying to get the charging cycle or the pricing cycles down to as little as 5 minutes, so that they can get people to very rapidly switch from coal or nuclear energy to the renewables to really drive that part of the business. So that's one example. There are lots of touch points across that, and it's really important as a regulated industry. Similarly, wastewater transport, vehicle to X, so smart cities and managing transportation. All of these areas, they have to have confidentiality, but more importantly even, they have to have integrity. They have to work, and then they have to have availability. They have to work all of the time, and if something goes wrong, they have to come back up very, very quickly.
And one of the other things, I think, the obvious question is, UK based, UK government grants, UK funders, but your market is Europe and US, and you're talking to people around both
Yes.
Europe and the US, is that right?
Absolutely, it really is global. Anywhere which has adopted, IoT security standards is a target market for us. So UK, Europe, US are all stakeholders in the CHERI technology. The changing regulatory landscape is also going to drive a lot of this, whether it's CRA or RED in Europe. The PSTI regulations here in the UK are still driving that, and similarly in the US, although we'll see how that evolves over the next few months.
Now, I've known you for a few years involved in cybersecurity, IoT security, and I've heard similar messages from you in different roles and different guises. What's the next thing that you want to achieve with SCI? What's the vision over the next 12 to 24 months?
So it's really working with government and the partners to drive adoption and to drive the strong acquisition use cases. So looking, as you say, at things like smart meter implementations, looking at automotive, perhaps post-manufacturing implementations, and some of these other areas. We're obviously a new company, and we have to address the marketplace through a set of beachheads, and then utilizing some of the seed money and future funding, and then drive out of those beachheads to take a wider position in the marketplace.
Well, Haydn, thank you very much.
Thank you, Nitin.